Alright, let's work on writing the standard form of an equation for lines when we're given the slope of the line and we're given a point on the line. Alright, so yes. Here's the standard form of a linear equation. It's some integer times x plus some other integer times y equals some integer. And it's nice when a is not negative. You can always, if a happens to be negative when you're working on these things, you can always flip the signs of everything and make it positive. It's just nice. It's good style. So the way I propose to do this is to actually first um, write the equation in point slope form first, because that's very easy to do when you're given the slope and a point, hence point slope, right? So you can easily convert that information to equation that's in the point slope form, and then from there it's pretty straightforward to convert the point slope form into the standard form. So that's the method I'm going to do. If you want to do it another way, that's fine. I think this is for me this is the most intuitive. So yeah, so using this information to write a point slope form equation and then playing around with that until it becomes a standard form. So let me show you what I'm talking about. All right, we've got a line here. It doesn't look like a line because we didn't graph it, but trust me, it's there somewhere in math space. And the slope is 3/4, and one of the points on the line, of which there are an infinity, is the point 2, 5. X is 2, y is 5. Okay, so let's use that to write a point slope form equation first. And all this says is y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. So this is x, this is y. Um, so in this equation, we call this x1, y1 to indicate that we're talking about a particular point on the line, not just x and y in general. Okay, so let's write the slope point, or the point slope form. Y minus the y coordinate of a point on the line is equal to the slope, we're given that. M means slope, stands for slope. 3/4 times x minus the x coordinate of the point. That's all that is. Okay? So now let's mess around with this until it looks like this. So first, distribute that slope. So we have 3/4 times x, and then 3/4 times -2 is or 3/4 times 2. When we subtract that, would be 6/4. So what is that? That's 1.5. Let's just call it 6/4 for now, actually. Deal with it later. Okay, so we've got y minus 5 equals 3/4 x minus 6/4. So we want to have the x's and y's over on one side and then just a number on the other side. So let's subtract that 3/4 x to move it over. So we've got now we've got minus 3/4 x. I'm kind of switching the order of the x and y. Plus 1y. Just don't want to make it look more and more like that. And then we still have that -5 over there is equal to, so we move this, so all we have left is that -6/4. I'm just leaving it as -6/4 for now. There's no reason to turn it into a mixed number. Definitely not a decimal. Don't turn stuff into decimals. It'll just make it a pain to write the standard form. Okay. Let's get that 5 over there. So we can just have x's and y's on the left side. And I'm just going to write this as negative 6 fourths plus 5. I'm not even going to add those yet because um, I don't know. I'm lazy. Watch this. So okay. So ignore that for a second. I've got negative 3 fourths x. Okay. A, B, and C need to be integers, not decimals or fractions. Okay. So I need to turn this into an integer, and I would really like it to be positive. So I'm going to multiply this. I'm going to multiply everything by negative 4. Here's why. If I do negative 4 times negative 3 fourths, I get negative 4 times negative 3 is 12. 12 divided by 4 is 3. So if I multiply this by negative 4, all that I'm left with is 3x, and that's a positive integer, so I'm happy about that. Now, because I can't just choose one term in the equation and multiply it by something. I have to multiply it, both sides of the equation by negative 4, just so the equation remains true. So I already did this. Negative 4 times negative 3 fourths x. Now negative 4 times 1y would be just negative 4y. Now negative 4 times negative 6 fourths would be 20. Negative 6 times negative 4 times negative 6 is 24, positive 24, over 4, which would be 6. So that just becomes 6. See why I just left it as a fraction? I knew I was going to multiply this stuff by some stuff, so it was going to work out. Now, negative 4 times 5 would be negative 20. So, see how much easier that gets? 6 minus 20, that's negative 14. Right? So, don't worry about leaving fractions as they are, for a while. So this equation, at long last, is 3x plus negative 4y equals negative 14. I've got some number times x plus some number times y equals some number, and these some numbers are all integers, and a is not negative, so that's good. If a needs to be 0, that's okay. If you don't have an x or you don't have a y, just call it 0x or 0y. Yeah. Okay. That was a lot. So let me see if I can. Let me run through another one, and then I'll let you do the last one. So let me scoot this down and give us some room. I'll let you do this one. There's a random dot there. Okay, not relevant. So, okay. So first, let's put this in point slope form. So I've got y. I'm gonna change colors so that I'm working on the second thing. Y minus the y coordinate of the point that's on the line, so y minus 7, is equal to the slope, which in this case is 2, times x minus the x coordinate, so minus negative 1. So something minus negative 1 is just plus 1. So I've got, now let's distribute this 2. So 2 times x is 2x. 2 times 1 is 2. So I've got y minus 7 equals 2x plus 2. Now, the x's and y's need to be on one side, so we subtract that 2x from both sides of the equation. So I've got minus 2x plus 7. No, I could have said, sorry, actually I wanted to do y next. But anyway, actually I need to do y next. I could have done y minus 2x minus 7, or y minus 7 minus 2x. I just want to put this in an order that looks more like this. So negative 2x plus, and I'm going to call that 1y, just to start making it look like this. I'm just going to call y 1y. So minus 2x plus 1y minus 7. What do we have left over here? So it equals 2. Now, what's this constant doing over here? Let's get it over on the right side. So it's minus 7, so I'm going to add 7 to both sides. So let's move up here. Negative 2x plus 1y equals 9. Now this is pretty good. All these are integers. -2, 1, and 9 are all integers, but I'd really like this to be positive. So I can just multiply everything by -1 just to flip the sign. So -1 times -2 is just 2. So that's 2x. This becomes -1y, and this becomes -9. So let's take a step back. Is this okay? So we've got something times x plus something times y equals something. These somethings are all integers, and a is not negative, so we are happy about that. That's standard form. All right, see if you can do this one. I would recommend converting it into point slope form first because it's kind of immediate to write that just given the slope and the point. You could write, if you're really committed to the slope intercept form, you could write it in that form first and then convert from there if you want to, but there'll be an extra step or so in there. But hey, I'm not going to stop you. All right, enjoy, have fun.